Hello, guys. Welcome back. So today we're going to talk about the organic molecule, the organic compound. So what are the organic compounds? Do you guys still remember? So organic compounds are those four compounds, right? If you don't remember, please watch my previous lecture, previous video. So what we have: protein, carbohydrates, lipids, nucleic acid. And what's their major function? So you should know that. All right. So that's gonna be in the quiz. All right, so we are going to dive into it. What is the major feature of the organic compound? The major feature, as we mentioned earlier, is that it contains carbon and hydrogen. But you may ask, why does carbon make it so special? Yeah. Why does hydrogen make it so special? Yeah. So you may have that question, right? And I will say that it's not that they make it so special. It's just they all have it, right? What make organic compound the organic compound? One feature that you don't usually see in other inorganic. Usually, I have to say that usually natural has always has exception. So usually you don't see in other compound like inorganic. You don't see in the inorganic compound is that the inorganic compound doesn't form polymers. So let me write the words out so you know what I'm saying. Polymer. So inorganic compound do not usually I have to say that I have to repeat that usually do not form polymer because there are exceptions. Yeah, usually. Yeah. Let me get a pens and a pen. Get one pen. I don't need pens. Just need one pen. It don't form inorganic. Organic form. This one form. All right. My FORM. All right. Form. Uh, polymer. Polymer. Yeah. What is polymer? Polymer means that it's poly, meaning that it has multiple. So you can kind of think that the organic compound is very unique. It's one can bind with their own and their own and their own. So you have one thing, it can bind the other, bind the other, bind the other, and it can form a string. Same thing is very much like Lego. You have one Lego attached to the other one, attached to the other one, attached to the other one, and you can use it to build castle. You can use it to build car. You can use it to build a house. You can use it to build a ship, a boat, right? So that is like that. Inorganic compound, you don't see that feature. Uh, Salt, water, you cannot put two together and to form a stuff. You can mix them, you can put them together, but they are not going to form a string. Yeah. They cannot use them to form a polymer. And that polymer is very helpful because without polymer, we cannot, with one polymer right here. So you have one, right? With a polymer, like this one, like this string, right? If you have one polymer, you can use this polymer. Say this polymer is very long. Say this polymer is very long. You can use this polymer to folding and like a cloth. Cloth basically come from the string, right? This is knitting, put together, become a cloth. Yeah. So that's that. So organic compound, the major feature is that they can form polymer. And so each organic molecule can be break down into single monomer, MO monomer. NO, mono means one, monomer. Poly means many, monomer, monomer. So each organic compound or organic molecule can break down into monomer, and the monomer can build polymer. Polymer can break down to monomer, and monomer can be a polymer. So that is the beauty of organic compound. We're gonna talk about these relationship in 4 compounds. Protein, we're gonna talk about their polymer and breakdown into monomer. Lipid, we're gonna talk about their polymer and breakdown into monomer. Carbohydrates, we can talk about their polymer and breakdown into monomer. And nucleic acid, the same thing, polymer and then breakdown into the monomer. What you will need to learn is their monomer and their polymer, and then also this reaction process. Yeah. So that's that. So learning objective or learning outcome, we're gonna learn about understanding the monomer and the polymers of 4 organic compounds. We're gonna describe the chemical reaction, include dehydration synthesis. So right here. So this process, when it form polymer, it's a synthesis. So this process is called dehydration. When you form polymer, you produce some water. Several monomers put together, you produce some water. So you dehydration synthesis. So this process, this one is dehydration synthesis. This one is hydrolysis. Lyse means break. Yeah, so right here. So dehydration synthesis is role in forming polymers from monomer. Hydrolysis is breaking apart, break down polymers into monomer. So you already know now. Yeah, we're almost done. We're gonna talk about another thing. These process our body basically is doing these over and over. Polymer basically are food. So you eat your chicken. Chicken basically is protein and lipid, something like that, and carbohydrate and organic compound, basically. But those are big stuff, right? You need to cut it, chew on it, and eventually you break those polymer to monomer. So your stomach, your intestine, your gut can absorb them. So this process is called catabolism. Digestion. Another way to say it is catabolism. Uh, when the monomer got absorbed into your body, you use it to build your own muscle. So you put them together. So you form polymer in your body. And so that process is building, and that building is called anabolism. And altogether, your body basically do this over and over again. You wake up, drink some milk, get some bread. That is breaking down your food. And then your body immediately put them together to form something that your body need, like repairing the cells, growing your body, produce new cells in your skin. Yeah, so that's put together. So you always have this catabolism and anabolism. You have the polymer breaking down or polymer formation. So that's that. So catabolism, anabolism, and altogether this is called metabolism. So we're gonna know that, and we already know. So almost done. This lecture is pretty easy, almost done. And so we want to know about each feature, each type, the feature of each type of the organic molecule. So what is the feature of the lipid? We kind of talked about that already. We're gonna talk more about it. What is the feature of protein? What's the feature of carbohydrates? What's the feature of nucleic acid? Yeah, so gonna learn more about each of these. So the first thing here is to understand. So here we're gonna learn about these 4 organic molecule and understand their monomer and the polymer. Before we dive into each of these, we should know that the feature of organic compound is that they can put together to form polymer. So here is the example. So you have one monomer. This is a short polymer, and these two can put together to make it longer. So this one is 1, 2, 3. You can add one to it, add one to it. so you can elongate it. And so this is a process to form longer polymer. And this process this reaction is called dehydration, meaning that it produces some water. Synthesis means that right here, dehydration synthesis. Here, dehydration synthesis, meaning that it's synthesized, meaning that it's formation. Yeah, so you don't break down, you form polymer. Yeah. Dehydration synthesis, and this process is an anabolic reaction because you building things. It's not breaking apart, building things. On the other hand, so this what happens in your cell, in your body, you put all these components together, and then you can form polymer. On the other hand, you can break things apart, like eating food. So the food is big, you cut it, and then in the end, you want to break it down into the monomer level, so your guts can absorb them. Yeah. So this process here, you have 4 break apart. This one is a monomer. This one is still a polymer, shorter polymer. So this will be continued cut. This is the digestion process. All of these formation, digestion, anabolic, catabolic, this is catabolic. So this process is called hydrolysis, break apart. This is a catabolic reaction. Yeah. Whether that's anabolic, catabolic, all of these require enzyme. You cannot just put 2 together and just hoping that they will form a polymer. You need an enzyme. Basically, you need a protein enzyme to facilitate this reaction. Yeah. So that's this catabolism, anabolism. And this one is also called dehydration synthesis. This one is called hydrolysis. You need a water to it. It help to cut, but you also need enzyme. You cannot just hoping that put in water and then they all dissolve. These compounds are not that easy to get cut. Okay, you need enzyme. Yeah. So this one lead us to understand the chemical reaction. There are many chemical reactions in the body, but in terms of organic chemistry, major process that we are facing day and night are catabolism and anabolism right here. Breaking down the food, breaking down nutrients for absorption. Anabolism, use those monomer to build your cell, build your body, anabolism. And all of this together collectively is called metabolism. So why is metabolism? This help with your metabolism, basically help you to digestion. You need to have healthy guts. Otherwise, what you eat may not be absorbed well. And catabolism meaning that in your body need to have the capability to put things together. Otherwise, even though you absorb them, you don't build your body accurately. That's not good either. Yeah. So that's the metabolism. So it's important, like cycle, breaking down, building it, breaking down, building it. Yeah. So that's that. So here I'm showing you the basic idea about the metabolism. It involves catabolism and anabolism. You take the food through the digestive system, you break it down. That is catabolism. In your cell, in your body, you put those together to form the structure that your body need is anabolism. Yeah. So, and we can do it because all these organic compounds are able to form polymer and are able to break down to form monomer. And that's why we can always do that. Putting together, it's like Lego. So organic compound is very much like Lego. You can break apart. Each piece of the Lego is a monomer. Put them together is a polymer. So you can always use it to build so many different things. And you can also collect a Lego like structure from other organism like plant, like chicken, and then use there to break apart. So collect, then you can collect their body, right? And break it apart to collect their Lego piece and use it to build your own body. So that's like part of you come from the chicken, part of you come from the milk you eat, you drink, and part of you come from the bread you eat, drink, put together and build to build your body. So molecule that we can absorb are four main one. Is here it only show you four, but different four, all right? Carbohydrates, we mentioned about that. Very important energy source. Protein, you need protein. So you just eat protein, right? And then you break it down to get their monomer. Lipid, the same thing. Fatty acid, that's lipid. Vitamin, that's a nutrients. This one is a little bit like, it's not polymer. Yeah, but it's important. It's trace nutrients. Yeah. So it's all of these are organic compound. Yeah. So let's start by looking into the carbohydrate first. So so carbohydrates are organic compound, and so you will know that they have their monomer, and then two monomer put together to form di. Two means di, right? Di here. And then more put them together to become poly. And so you can have monomer to form, put together to form polymer. Now we need to know what's their monomer. So carbohydrates, a simple way to say it is basically sugar stuff. There are many kind of sugar. You probably know that already. You can have a table sugar. You can have a fructose right here. This one is basically it's more commonly seen in the fruit. It's different from the glucose. Yeah. And so they are different kind of sugar. Yeah. And so their monomer, the very single piece of the Lego piece, are three major form. In human body, there are way more, a lot more. But in your human body, we commonly see these three form. And we use these three form as the energy source. We have the glucose, galactose, and the fructose. And because this is monomer, we also call these, in the carbohydrate, we call them monosaccharide. Saccharide. Yeah. So monosaccharide, which of the following is a monosaccharide? Glucose, fructose, galactose. All right. So that's monomer. You can put two together, and in our nature, we commonly see two together. We can see more together, but more together like this bread it's difficult to use. And the two together is already processed. That's why we call it processed food. Like all your processed food is bread is processed, but it's not processed to a level that is smaller molecule. So if you put two together, depending on which two, you can form different type of disaccharide. Di means two, disaccharide. Yeah, so this monosaccharide, disaccharide, that means two. So if you do put two together, meaning that you form dehydration synthesis, put right here, dehydration synthesis, right here, put two together, dehydration synthesis, right here, or an anabolism, anabolic process. If you put this glucose right here, glucose and fructose, this become sugar, sucrose. Yeah. So this is very common thing. Like when you buy like white, like table sugar, that's sucrose. Yeah. It's powder form. Yeah. And if you do put glucose and glucose together, if that compound contains two glucose, if that disaccharide contains two glucose, it's called maltose. And so that's another disaccharide. This one easy to digest in our body because our body use glucose. Glucose is primary form that our body use. Fructose, you need to go through liver, so we cannot use them directly. Liver will convert it into other energy source. Your cell can directly use glucose. So fructose, in a way, is not as healthy because it has to go through liver. It adds the liver, increase the liver burden to work. So glucose is easier. So that's why we eat bread. Bread is more recommended than drinking juice. Drinking juice is a big no-no. Yeah, it's not good for you at all. You can eat fruit, but don't drink juice. Drink juice contains too much of the fructose or even sugar water contain a lot of fructose, and the fructose increase your when you go into the body very quickly. This one you don't need digestion. Fructose you don't need digestion because this is already a monomer. You can just take it in, and then it will increase the fructose level high very quickly. Bread you need digestion. You need to chew on it. You need to break it apart. Bread basically is right here. Starch is polysaccharide. So you need to piece it out. You take time to break it apart. And that's good for you because then you don't give your body a shock. Like all of a sudden you have too many sugar into your body. Yeah. Lactose is each lactose contains one glucose and one galactose. And so some people do not have the enzyme to break this apart. You can drink milk. Milk contains lactose. And some people do not have the enzyme to break lactose into glucose and galactose. So they have the lactose intolerance because if you don't break them, you are not going to absorb them. So in your guts, you need to have the enzyme to break lactose to glucose and galactose. But not everybody in adults. In baby have the enzyme because that's their major form of carbohydrates from milk. But when you turn adult, some of these enzymes just gradually decay because not everybody drink milk like every day, and so your body do not prepare for drinking milk, and so you have the person may have the lactose intolerance. Yeah, because you don't break it, it will stay in your guts, and when you stay in the guts contains many bacteria. Bacteria will use it, and then they will be pretty happy. And if your guts bacteria is too crazy, then you feel uncomfortable by those activity. Yeah. So that's that. So that's disaccharide. Each molecule contains two monosaccharides. Now, if you put more together, that's a beauty of the organic chemistry, organic compound, that they can form polymer. So if you put more together, they form polysaccharides. So this is more natural form of the food. This is recommend, because then you need to take time to digest, and it reduce the burden. It doesn't allow your body to, because yeah, so this is the more natural form. Yeah, so that's a better thing. So starch, glycogen, cellulose, these three are the common example of polysaccharide. Our body can digest starch. Our body starch basically is formed by glucose, all together glucose. I can show here starch right here. Glycogen, same thing. Glucose, all of this glucose. So our body basically uh, uh, is designed to take in glucose. And our body, when you have extra glucose, we put together, form glycogen, and we store the glycogen in the liver and the muscle. Yeah, skeletal muscle. So we store them. When we need it, we just take a piece out, give the piece out, and so your body has glucose to use. Starch is the polysaccharides present in the bread, in the pasta. Those grain contain a lot of starch, so it's the uh, recommended source for you to get carbohydrates. Cellular also seen, this is called dietary fiber, meaning that these fiber is important, like making clothes, those are fibers. Yeah. But this dietary fiber from the plant, human body, not all animal, some other animal can dissolve it, can digest it. Human body cannot digest cellulose. And so cellulose become a primary form to boost the uh, feces formation. Basically, it help you with your gut, help you with the bowel movement, like guts, and to allow you to poop better, like every day. Yeah. So that those three are the polysaccharides. All right. So that's that. So here is a polysaccharide example I showed you earlier, carbohydrate. So here you can see polymer. This single one is the monosaccharide, polysaccharide. Yeah. So that's the carbohydrates. Um, let's take a break, and then we continue with the lipid.